6.1 is on law of sines. Okay, law of sines is used to find the missing sides of angles of triangles that are not necessarily right angles, although they can be used for right triangles as well. Okay, first we're going to do the area of an oblique triangle, which they give by this formula. Okay, I'm going to show you where the formula comes from. You don't need to copy this part, but I just want you to see that you don't actually need to memorize that formula so much as you need to see where it comes from. Okay, the standard protocol is that the side opposite the capital letter angle is a lowercase letter. So because this is a capital letter on the angle, if I go across from it, this should be little a. So across from big B should be side little b, and across from big C should be side little c. And I'm using these letters just to match the protocol. Okay, normally to find the area of a triangle, I do area equals 1/2 base times height. Okay, now in this case, the base happens to be B, but the height is not indicated. So I'm going to draw in the height. Okay, now if I wanted to find the height, I could use SOHCAHTOA. If I started from angle A, I might say that the sine of A equals H over C. And I would say that H equals C times the sine of A. And now if I substitute the height equal to C sine A, then I get the area is 1/2 BC sine A. Okay, now because the orientation of the triangle rotates, they show you it with a bunch of different variations on the letters, but the only thing that really matters is that this angle is between the two given sides. Okay, so for example, when I'm going to use this formula to calculate the area, and I'm not going to worry about the ABC, I'm going to worry about whether the angle is between the two sides. Okay, so I'm going to draw a picture, although I wouldn't really need a picture at all for this. Okay, I'm drawing a random triangle. Find the area of a triangle with two sides of lengths 34 meters and 25 meters. It doesn't say which side is which, so I'm just going to randomly label them. Okay, included angle of 104. Included angle means between angle. So between the 34 and 25 is 104 degrees. This is not drawn to scale. Okay, now according to the oblique triangle area formula, the area is 1/2 the side times the side times the sine of the included or between angle, which is 104 degrees. Okay, and this is the one chapter where we are going to be using our calculator a lot. Okay, so I'm going to put that entire expression into my calculator. Make sure you are in degree mode. Switch back after chapter 5. Okay, and I'm going to get 412.38. For units, these are meters, but because it's area, it's square meters or meters squared. Okay, and just make sure you write the first step as your work, and then the rest just gets plugged into your calculator. Okay, now we're going to actually get to the law of sines. Okay, and I'm going to redraw the triangle just for reference. You don't have to draw the triangle. Okay, we often use ABC. ABC are the vertices or the angles. Capital ABC, I should say. Okay, it doesn't matter which one's which, but it does matter that the side opposite the angle has a corresponding letter, but little. So across from big A is little a, across from big B, little b, across from big C, little c. Okay, because of that naming protocol, you often don't need to actually draw the picture to solve the problem. Okay, so for example 2, it says given A is 35 degrees, and yes, I would like them to write the measure of angle A, but it's standard to write capital A equals 35 degrees, B equals 51 degrees, and little a equals 16 feet. Find the remaining sides and angles. Okay, another way for them to say find the remaining sides and angles is they will say solve the triangle, which means find all the measurements of the sides and angles of the triangle. Okay, I am going to sketch a picture, but a picture is not necessary for this. Oh. My triangle's struggling a little here. Okay, let me see. A, B, C. Since the picture is not drawn to scale, angle A is 35 degrees, angle B is 51 degrees, and little a is 16 feet. I need to find all the missing sides and angles. Let's see. Okay, I'm going to use the law of sines now. Okay, this is the law of sines. Okay, where does the law of sines comes from? Okay, let me go back up to the oblique angle formula. Okay, now this formula is written 3 different ways. If I set 2 of the ways equal to each other, just look at the last 2. Okay, if I set them equal to each other, the halves would cancel, the c's would cancel, and I would have b sine a equals a sine b. Now, if I divided the sines to the opposite side, I would end up with a over sine a equals b over sine b, which I could also, if I use the other equation, make it c over sine c. So this ratio is always true. It is also that the reciprocal is true. So if it's more convenient to make it sine a over a equals sine b over b, which equals sine c over c, you could also do it like that. Okay, let's get back to our example. Okay, let's see, I need to find all the angles and all the sides. I'm going to find the angle first because I already have 2 of the angles. And of course, I do in fact know that the angles of a triangle add up to 180. So if I do 180 degrees minus the sum of the first angles, 51 and 35, I should be able to get the remaining angle, which is 94 degrees. Okay, and you can use your calculator. You will need your calculator for the next ones. Okay, let me look at the next one. Okay, should I get B or C? Doesn't really matter at this point. Let me label the 94 degrees here. Okay, so I'm going to go ahead and get B, I guess. So according to this ratio, if I do B over sine of big B, which is 51 degrees, I could set that equal to a given side over the sine of the angle. So I could say it equals 16 over sine 35, or I could say it equals C over sine 94. Okay, I would rather use the 16 because I don't want to introduce a second variable. So since I know another side, I'm going to do 16 over sine of 35 degrees. Okay, and I could have done that again without drawing a picture because from the given problem, I can see that which angles match. So I could have said 16 over sine 35 degrees equals B over sine 51 degrees because I can see that the A goes with the A and the B goes with the B. Okay, I would probably multiply sine 51 degrees to the opposite side of this to solve it. I leave it up to you how you solve it as long as you set it up and put it in your calculator. I will check your setup. I will check your answer. And I get B is about 21.68 feet. I'm going to go back at the end and make sure my answers are reasonable. Now for C, let's see, C over sine of 94 degrees because I discovered that angle. Let's see, I want to pick another side I know. I could use my answer for B, but I'm just going to use my 16 feet again. That way if I made a mistake, it won't lead to another mistake. Okay, I would probably multiply sine 94 degrees to the opposite side, but how you solve it is up to you. Okay, so I've found all the sides and all the angles. This isn't a check, but if I use the triangle inequality theorem, I can kind of triangle angle side inequality theorem, I can kind of check if my answers are reasonable. So if I go to the smallest angle, it should be opposite the shortest side. So 35 degrees is opposite 16 feet. The medium angle should be opposite the medium side. 21.68 is the medium side, and the largest angle should be opposite the largest side. So 27.83 feet happened to be the largest angle. It doesn't tell me for sure that I did it correctly, but it does help me have an idea. It will help me catch mistakes if there are mistakes. Okay, I'm moving to example 3. We're going to find an angle on this, and I'm going to kind of show you that sometimes there is a little bit of a twist. I'm going to do this without drawing a picture this time, okay? So they're giving me that the side A is 12, the side B is 14, and the measure of angle A is 40 degrees. I want to find capital B and C, which means I'm finding the angles. Okay, now if I don't want to draw a picture, I'm going to match up the letters. So I'm trying to find angle B first. Since I'm finding the angle, I like to put the sine of B at the top. I can do that as long as I always order my ratios that way. Okay, the sine of B should be over the side B. The side B is 14. equals, okay, I want to set it equal to a known quantity. So the sine of, the only angle I know is A, so the sine of A is sine of 40 degrees over the side A. Side A is 12. So sine B over sine A over A. Okay, now when I solve this, I normally can't do it all in one step. Okay, I am going to multiply the 14 to the other side and put it in my calculator or save the expression or something. I get about 0.7499, blah, 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 blah. I do want to keep a lot of decimals on it because when I do inverse sine on it, because in order to solve for the angle, I need to use inverse sine. If I lose a bunch of the decimals, I lose a lot of degrees. Actually, it's going to mess up my angle fairly significantly. Okay, now this seems like a good angle, and I actually do like this angle. So I'm going to go ahead and find angle C with this angle, and then I'm going to go back to this particular equation and think about it again. Okay, now if angle B is 48.58 and angle A is 40 degrees, I can now find angle C just by subtracting. Okay, now I'm going to go back to my sine B equation. Okay, and there is a small problem. Okay, the problem with the sine of B equals 0.7499 equation is that if you remember from chapter 5, we normally get two different answers for the sine B equals 0.749. Okay, so there is a second possibility here, and I need to check it and see if it's going to work. Okay, so for my second angle B, I'm going to call it B prime. Okay, now if you recall from chapter 5, if we were solving an equation using inverse sine or arc sine, if we found one answer to be x, the second answer was pi minus x. Since we're working in degrees, instead of making it pi minus x, we're going to make it 180 degrees minus x, which in this case we found our angle to be 48.58 degrees. So if there is a B prime, it's 131.42 degrees. Okay, at the end I'm gonna go back and see if this answer makes sense, and I'll give you some ideas of when it might not make sense. Okay, but if there's a B prime, then there's also a C prime. Okay, so C prime would be the 40 degrees for A, which was given, so that's not gonna have any alternates. Plus, what if angle B is actually 131.42 degrees? I need to consider that scenario and subtract it. Okay, now before I actually move on, I'll show you what might happen if this didn't work. Okay, let's see. B prime, if I got a negative answer for B prime or C prime, that would mean that the entire primes were invalid and I would cross it off. But I got a valid answer for B prime and I got a valid answer for C prime. Let's see, if I knew they don't give me more information, but if I did the triangle and side inequality theorem, that would be another way to check and see if the answers made sense. Because if it failed the triangle side inequality theorem, it might mean some of the answers are invalid as well. And so when we get to something like that, I will show you what that looks like. Okay, let's take a look at this one. I know the numbers, the letters are out of order, and that's because I later realized I wanted to show you them in a different order and I didn't change the numbering. Okay, it says this is another find angle B and C, and I'm kind of just trying to show you different scenarios that might happen. I don't need to draw a picture, but you can if you would like. I'm going to find angle B and angle C. So I'm just going to find angle B first. Since I'm finding an angle, I'm going to put sine B over this side B, which is 35. I'm going to set it equal to a known quantity, which in this case, the only angle I know is 78 degrees. So sine of 78 degrees is angle A over side A is 7. Okay, I'm going to go ahead and solve this. So I get this sine of B. I'm going to keep a few decimals on this. I'm going to get 4.89. Okay, now in order to solve for B, you would do inverse sine of 4.89, what you can try to do in your calculator, or you can recognize right now that that's not going to work because the range of sine is between -1 and 1. Okay, but again, you're using a calculator this chapter anyway, so if you do inverse sine of 4.89, it's going to give you some kind of error. And what that error means is that it's not possible to have a triangle that's like this. So this is not even a possible triangle. If you tried to construct this triangle, something would fail. The sides would not connect or something like that. Okay, now we're going, to the next problem. It's a similar scenario, but I'm just trying to show you different situations so you know what conclusions to make according to them. Okay, so I'm still finding angle B and C, and I'm still going to start with angle B not for no reason, because I don't have side C. So sine of B over 12 equals, I'm given angle A, so sine of 42 degrees over side A is 22. Okay, sine of B, I'm going to multiply by the 12, and I'm going to hold on to my decimals, or if you know, for your calculator, just use the answer function for the inverse sine. Okay, I'm going to do inverse sine of this thing, and you don't need to write out this step, but sometimes people forget how they got the answer, so I'm writing out that inverse sine step. I got about 21.4 degrees. Okay, let me go ahead and find C, and then I'm going to consider the alternate answer. And the alternate answer occurs only with law of sines. So C equals 180 degrees minus the 42 degrees plus the 21.4 degrees, or however you do this. I get 116.6 degrees for my missing angle. Okay, now let me consider B prime, because when I use inverse sine, I get a second answer, which is pi minus x, or in this case, 180 degrees minus x, which is 21.4 degrees. So it's possible that angle B could also be 158.6 degrees if I were to construct this triangle. Okay, now if B prime is 158.6 degrees, let me calculate C prime. Triangle adds up to 180, so 180 minus angle A plus angle B. Okay, now if I put this in my calculator, I actually get negative 20.6 degrees, which makes no sense. And I didn't even really need to put it in my calculator because I can see that 180 minus 190, higher than 190 is going to give me a negative value. Okay, you can't get a negative angle on the calculator. So if the C prime does not make any sense at all, then the B prime also doesn't exist because they exist on the same triangle. So that entire alternate prime triangle no longer exists. Okay, so in this case, there's only one value possible for angle B and one value possible for angle C. Okay, this chapter is also going to have some word problems. Okay, before we get to the word problems, I'm going to introduce the idea of bearings because they're strange and other kinds of angles. Okay, before we do bearings, let me make sure you know northeast, southwest. Okay, I do have a mnemonic, but I'm not going to put it on this video. So N-E-S-W. Okay, it will be helpful to know which one's which. Okay, bearings start in the initial given direction, and then they open the angle according to the last direction given. So what does this mean? So this is what a bearing looks like. It says south 32 degrees west. It has a letter, an angle, another letter, a direction letter, I should say. Okay, so I start in the initial direction. So initially it's telling me it's south. So if I go south, I'm going this way, theoretically. Okay, it's going to open according to the last direction. So this is going to open 32 degrees to the west. Okay, the west is to the left. So I'm thinking this is going to be 32 degrees in this direction. Okay, and then this is the angle they're trying to get you to draw in your picture. Okay, let's go ahead and look at the next one. Okay, this is again, it starts in the south direction, so south. Then it opens 47 degrees to the east. So from the south line, 47 degrees So the east would be over here, and this is the angle they're trying to make you create. Okay, let me keep going. North. Initially, I'm going north. From the north line, I'm going 14 degrees to the east. So I'm going this way. Okay, and then the last vocabulary that you probably remember from geometry. Okay, angle of elevation is always up from a horizontal. It doesn't actually matter where your horizontal is because all horizontal lines are parallel. But if I have a horizontal line, the angle of elevation is always going to go up from the horizontal. Okay, if it's angle of depression, it goes down from a horizontal. Okay, and it doesn't always matter where the horizontal line's drawn. It depends on your picture. That's because all horizontal lines are parallel. So down from the horizontal means the 46 degrees goes down this way. And I would draw my picture like that. Okay, now after all that, now let's actually try to solve a problem. Okay, let's see. A boat is traveling from point A to point B at a bearing of north 82 degrees west. Okay, first let me kind of have a general sketch for it, and then I will have to adjust my sketch as I go because these are not the easiest. Okay, so it's going from point A to point B at a bearing of north 82 degrees west. So it's kind of going northwest from A to B. So from A to B, it's going northwest. Let me put this somewhere northwest. Again, I might have to erase something later in order to make this work. Okay, so this is its general path. Let me mark the angle they give me, which might not be the angle I want. Okay, from A to B, so from point A, he's going north. I'm going to draw the north line. 82 degrees west. So on the west side of the north line, it's 82 degrees. So the 82 degrees goes here. It's on the west side of the north line from point A. Okay, let's look next. Then the boat travels to point C at a bearing of south 36 degrees east. Okay, let me sketch it, and then I'm going to erase it and fix it. Okay, so from point B, he goes to point C. Point C is southeast somewhere. So let me just say I put it here. This is wrong. Don't copy it. Okay, now I'm going to keep reading. Point C is 15 miles due south of point A. Okay, so point C actually needs to be exactly 15 miles south. So let me rethink this. Okay, I'm going to make this 15 miles. I'm going to make this C, and I'm going to go ahead and redraw the path. Okay, and for these, I often have to redraw it as I add the information or as the angles don't seem to fit right. Okay, so this is my triangle. Okay, let me go back and get that bearing they gave me. Okay, so the boat travels from point B to point C, going south 36 east. So from point B, from the south, this is my south line. On the east side of the south line is 36 degrees. Okay, point C is 15 miles due south of point A. Okay, I got that. How many total miles does the boat travel? So it looks like I need to find the entire perimeter of this situation. So I need AB, I need BC, and I already am given AC. Okay, now the problem is none of the angles they gave me are actually interior to the triangle. So I'm going to have to figure out some of these angles. Okay, let's see, which one should I get first? I think I'm going to get the linear pair that's adjacent to 82 degrees first. Okay, if this is 82 degrees, I can get this interior angle because these are a linear pair, and linear pairs add up to 180. So if I do 180 minus 82, I get 98 degrees for this interior angle. Okay, I still need the other interior angles if I'm going to figure out the other values. And there's more than one way to do all of these. So you kind of have to look at it and see what you spot. But we should get the same values because the angles are fixed. Okay, I think I'm going to use the parallel lines. This is a south line. And the north-south line is also, these are two parallel lines. Okay, so if I take this angle of 36 degrees, and I follow it along the transversal, the alternate interior angle should also be 36 degrees. Okay, so let me see if that's 36 degrees. This alternate interior angle is also 36 degrees. That's one way to get it. Okay, if I know that two of the angles are 98 and 36, I could get angle B by doing 180 degrees minus 98 degrees plus 36 degrees, which gives me 46 degrees. Okay, depending on your geometry skills, you might have also gotten it seeing that this 82 degrees is alternate interior angle to these combined angles, which makes these add up to 82, and you could have gotten the angle that way. If your geometry book did same side interior angles, you might have noticed that 98 and these should be supplementary. So finding the angles, your geometry is kind of up to you. Okay, now that I have all the angles, I can find the missing parts. So I'm going to go ahead and find AB first. AB over, this is side AB up here. The angle that it is opposite to is 36. So over sine 36 degrees. The only side I am given is the 15 miles. So I'm going to do 15 over. And the angle opposite the 15 miles is 46 degrees. So sine of 46 degrees. I'm going to go ahead and solve this. 12.26 miles. Okay, now I need to figure out the distance from B to C. So B to C over the angle opposite B to C is 98 degrees. So the sine of 98 degrees. I could use my answer, but I'm going to just use the given side 15 over sine of 46 degrees. I can find BC that way. I get 20.65 miles. And if I double check the question, it's asking how many total miles does the boat travel? Okay, total distance. And do read the question because sometimes it's different. Okay, so he starts from A to B. A to B is 12.26. And then the boat travels to point C. So now from B to C, it's going 20.65. Does it go back? It looks like it doesn't go back to A, so it just goes from A to B, and then it goes from B to C. Okay, so the total distance is just those two values added up, so 32.91 miles. And I should read the question too.